We will begin lectures. I'm going to be conducting my lecture similarly to the way I conducted in class, which is reviewing the textbook and the concepts in the textbook and going over problems specifically in the textbook. And so my attempt is to be able to provide to you the same kind of delivery as what would be done in the classroom, but we're going to do this via video. Okay, so hopefully that will compensate for the fact that this is an online class, but rather than being completely online without any kind of lecture or instruction, we'll go ahead and provide as much guidance as we can through the video lectures. So we'll start with whole numbers and decimals, and that's chapter 1. The 5 areas we're going to be dealing with are whole numbers, application problems, decimal numbers, addition and subtraction of decimals, and then finally multiplication and division of decimals. For many of you, this is going to be a bit remedial. Many of you, these kinds of computations are going to be relatively simple. And I say relatively simple because math can get much more complex than this. But by the same token, I don't want any of you to feel as if you feel like you're already struggling with some of this. It's not extraordinary, it's not impossible, and in many cases, some people who were learning this when they were younger, when they were in grammar school or whatever, whatever level of school you were being exposed to this, sometimes at that point in time, it wasn't the right time for many people. And so hopefully now that many of you are more mature than you were when you were first exposed to this, that this re-exposure, so to speak, will get you to a point where it really makes much more sense than what it did before. Now, in many cases, if I were going to write something down on a piece of paper in the classroom, I'll probably, since I can't write on my screen, I'll probably pull up a spreadsheet. And this is not a spreadsheet class, it's not an Excel class, but I'm just going to mirror what I would have written down in the classroom up on the overhead. I'll just mirror that on a spreadsheet. It seems to work just as well. In some cases, it'll be a little easier because I can use the computations, and that's the way it works. But let's see what we got. Well, the first objective is to define whole numbers. Define whole numbers is written in the textbook as the decimal system uses the 10 one-place digits from 0 all the way to 9. Okay. Combination of these digits represent any number needed. Okay, the starting point at this system is the decimal point period. So the period here is at the decimal point starting period right here. And then we can see that anything to the left of this would be considered whole numbers. This section considers only the numbers made of digits to the left of the decimal point. So that's the whole numbers. It's all on the left side. Any whole numbers here. So if you have 1, 2, 3, 4, all the way up to 9, this would be in this place. Once you hit 10, you come up to this and you have a 1, 0. So now this is your tens. You have 10, 20, 30, 40, jumps to the hundreds, 900, 800, 700, 600. That's for your hundreds, and then your thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, and you can see where the rest goes. I don't even know what comes after trillion. I guess when I have that much money, I'll be worried about it. In the meantime, we'll just go with what we got. All right. So in this case here, they have written out the question is how do you read this? And so I know some of you are going to look at this and say, really, are you going to this? But some of you are going to, it's something that we have to think about and focus in on, because we don't do this all the time. It's not something that all of us kind of hammer out. Well, in fact, I do, because I'm an accountant, so I'm always dealing with numbers. So this is relatively easy for me. But not all of us deal with numbers on our everyday jobs or with the things that we do on a day-to-day basis. So this is a very good class to help you practice. And I will tell you that if you don't continue to practice after this class, then it comes and it goes. So you have to take this, do your best, learn from it, and then continuously practice at it so that way it sticks, and that when you're dealing with issues or problems in the future, you're able to address them. Okay, so we look at the 5. The 5 is all the way over in this column. We cheat because we look at the commas here. So there's 2 commas, and if once we go 3 digits away from that comma, there's 2 commas in here. So we know Well, we already know we're in the millions section because we passed that second comma. The first comma would have put us in the thousands, but the second comma puts us in the million section. So now we know we're at the 100 million section. That's 581,075,900. Okay, so that's how you would read it, 581,075,900. All right, so there's a couple of problems here that I'd like you to go ahead and work through. There's not much that I could do here. Well, let's look at the first one here. Write the following numbers in words. Okay, so 7,835. If you want to write that out, that's 7,835. You can practice on that. The solutions are right there as well. And practice it first. You might want to cover up those solutions first and then turn around and see if you can figure it out. Now, believe it or not, we can round whole numbers, which is a bit of an interesting concept because in most cases when we learn how to round numbers, we're talking about numbers to the right of the decimal, which is not a whole number. It's less than 1, so it's on the right of the decimal. But in this case, we can round numbers, and we do this all the time, especially in business, because it's easier to deal with let's say you have a number of $102 and another number of $106, and you need to add those up. Well, we might just round those two numbers to the nearest hundreds, but not the hundreds backwards, where we're looking at the decimal place beyond or less than 1. We're going to go ahead and look at rounding it to the nearest hundred, not hundredths. Okay, we'll get to the right of the decimal. Remember that THS at the end, but this is just to the nearest hundred. So if I told you had 102, well, the nearest 100 to 102 is 100, right? And if I told you I had 106, the nearest 100 to that is 100. So if we wanted to add 102 and 106, for some of you, you can just automatically do that in your minds, but we might simplify it and say, okay, well, that's really 100 plus 100. So I know it's got to be close to 200. We know there's some extra digits in there, so that's not precise. But in many cases in business, we don't have to be that precise. In many cases, just know we're roughly 200. That's going to be good enough for us to make a decision. And so it's important for us to actually understand this rounding whole numbers concept, because in many cases, it'll make our lives a lot easier in trying to make a decision, especially when we don't have calculators in our hands or we're just trying to solve a problem really quick. So in this case, rounding whole numbers, you have example number 2. I'll put my cursor on it, round each number as indicated. So 579 to the nearest 10th. Well, we're going to look at the nearest 10th places. Well, this was a 1, this was the nearest 10 to the nearest 10. So we're looking at, well, the nearest 10 is going to be 10, 20, 30, 40, 50, 60, 70, 80. Well, it's 7, but we're going to do something that we probably have learned for decimals or to the right of the decimal point for less than whole numbers or less than 1 numbers. We're going to look at to the right of the 7 and measure that, whether that's 5 or above. And if it's 5 or above, we'll move this digit up. So in this case, we're looking at 579. We want to round it to the nearest 10. So 10 is here, the 7 spot. So does that stay at 7 or does that move up to 8? Well, because this is a 9, just the 1 digit to the right, it's a 9. That's going to push us up. So our nearest tens place is going to be 580. Okay, so your 570 round is round to the nearest 10, and that's 580. All right. There's B, C, D. There's nearest thousands, nearest 10,000s. I think you can kind of work through that. When you're doing that, just kind of first do it without looking at the notes, and then turn around and look at the notes and see if you were able to get it. But doing it, just remember that wherever you're trying to round to, let's say I'll give you the starter on the B. The B is rounding to the nearest thousands, so we're going to go all the way up to the first 1,000. That's here. It says 4 here. We have to decide whether that 4 is going to remain at 4, and we'll call this 34,000, or is it going to be rounded up to 35,000? And the hint is, let's look at the number just to the right of the 4, and that'll dictate it. So you can practice that. All right, adding whole numbers. This is pretty straightforward. By the way, for the first 3 chapters, I do not want you using calculators. The whole point of this is to practice practice our addition, practice our subtraction, so calculators are not allowed in the first 3 chapters. Now, a lot of this work you're doing on your own, so I get it. You know, well, how is he going to know? Well, maybe I have cameras built into all of your computer systems and I can see what you're doing. You never know. But in any event, just avoid using calculators. You might want to do it to double check things, which I get. But for the most part, the only way you can get better at this is to do this, to do it. You can do it manually, because not all the time do we have our calculators with you. For example, 8 plus 9 is 17. That's your answer. Now, for some of you, some of these numbers, we need to be able to get pretty skilled at and be able to add these numbers. It may not be quite that easy for us, and in many cases, some of us like to use our hands and our toes to count to get there. So what I do want to encourage you is to, at some point in time, and there are tons of tools online as well where you can get flashcards and you just practice adding specific numbers up. We all did that when we were in elementary school, but you know, that helps for us to kind of solidify what we know. For example, if 8 plus 3 doesn't come to you immediately thinking, okay, 8 plus 3, if it doesn't just click in your head, it's 11. And what you have to do is 8, 9, 10, 11. If you have to do it with your fingers, then you probably need some practice with some cue cards. All right, but anyway, so we have a set of numbers here, 738, 63, 125, 26, 17, and 45. And what it's asking us to do is add them both down and up. And this is a good practice anyway, even if you use a calculator, because it's so easy to enter a wrong number here. It's a good idea to first add it, you know, looking at the numbers from top to bottom. So you would enter 738, 63, 125, 26, 17. You just add all those numbers and then see what the calculator comes up with. Should be 4,028. But before you're convinced that you did everything correctly, then you turn around and in the same calculator, start it all over and enter 45, 26, 17, 125, 63, 738. And so by doing it this and then seeing if that number that you come up with is the same as the one that you came up with the first time, you can compare those, and if they're equal, then that's a better chance that you didn't miss out on a keystroke, that you didn't punch a wrong number, okay? In the meantime, we're not using our calculators right now. We're adding these up manually. So we're looking at, okay, so 8 plus 3 is 11. 5 plus 5 gives us 16. Plus 7 will give us 23. Plus 5 will give us 28. So we have our 8. We're going to carry up the 2. We're going to carry the 2, and then we know the 2 is here. We're going to take the 2 plus the 3 is 5 plus 6 gives me 11. 11 plus 2 gives us 13. 14. And then 14 plus the 8 gives us 22. So we have our 2 here. We're going to carry up another 2. 2 plus 7 is going to give us 9, 10, 16, 20. So we have a 0 here. And then we're going to carry up a 2. And the 2 plus this 2 is 4. So we get 4,028. And then, you know, to be safe, if we're doing this manually, we're going to go backwards. 5 plus 7 is 12. 12 plus 5 is 17. Plus 3 is 20. Plus 8 is 28. So we have 28. So you'll do that both down and up to make sure that you're double checking your numbers. All right. Now the important thing for addition is just to make sure that you've got everything lined up, that all your ones are lined up, all your tens, all your hundreds, and all your thousands. Now going back to that front end rounding, sometimes we look at things, and if you want to add these numbers, like what is that, 1,263,630,000. So that plus 552,975,000. You're like, I'm getting confused already. There's too many numbers here. Well, you can make your life a lot easier by just front end rounding. So 1,263,630,000. 1.2, well, we can round that to, if we want to round up, we're going to be looking at, let's just round that front end rounding, 1 billion. We just put that down, 1 billion. Put a bunch of zeros there so that way we're not dealing with so many numbers. 552 million, well, can we just, well, we look at this 5, we say, okay, we can go up, and that's 600 million. 429 million, 429 million will give us, really round it down to 400 million. 201 million, well, that can be rounded down to just 200 million. 176,295,000. Well, that 176 million, let's see, we're going to round that up to 200 million. Okay, so we didn't even talk about what we're counting, but we're counting barrels of oil that are produced. Texas, offshore, North Dakota, California, Alaska. So we're front-end rounding because we want to know what's the total amount. Well, it's kind of hard to add up all those numbers, but we can more quickly add up these front-end rounded numbers. So we plug these numbers in, make sure that the decimals are all lined up. We've got our million, 600 million, 400 million, 200 million, and 200 million. We'll add these numbers up. So now we have 6 plus 4 is 10, plus 2, 12, 14. So we have the 4. We'll carry the 1, 2. That carries a 2. So what we have is 2,400,000,000 barrels of oil. Now, the actual number, well, you can run these numbers and add them up specifically to get a specific detailed total. But this may be close enough. 2.4 billion may be close enough for you to know, to make a decision. So maybe you didn't have to do all the rounding or all the addition of all these specific numbers. Maybe you didn't have to do the detail adding. Maybe you could just do some front-end rounding and come up with a very quick number so that you know where you're at roughly, and maybe you know that that's close enough to be able to make a pretty good decision. Okay, the next section talks about subtracting whole numbers. Same concept here, you just want to be able to make sure you're lining up these numbers, all right? Make sure you're lined up the ones and the tens and the hundreds and the thousands if you have that. But in this case, we have 23 minus 7. So we're taking 23 and we're subtracting from 23, 7. That's going to leave us with 16. Now, if we were doing this manually, we have a 3 here and we have a 7. We're going to take 7 from 3, but that's impossible because that's taking more away than what you have. There's 3 here and you want to take away 7. That doesn't work that way. So what we have to do is, and I know most of us learned about borrowing, you know, you'll take the 2, you'll borrow 1 from the 2. Well, I don't like to call it borrowing because we're not going to give it back. We're going to keep it. So in this case, you're going to jack it. So you're just going to jack a 1. You're going to take 1 from the 2. That leaves you 1 here. That other 1 comes here. So you have a 1 listed here. So you have 13 minus 7. So 13 minus 7 gives us 6. All right. And then remember, we jacked the 1. So that's what's left. There's just a 1 here. So 1 minus 0 is 1. So that's how we end up with 16. All right, so you can take the 3783 minus the 2894, practice that out, and then check the solutions to see if it makes sense. I'm sure you can work through those problems. Multiplication, okay. In most cases, they're set up, you may find that they're set up horizontally, and that can work, except it's kind of tough to do it manually. You know, you'll like it if you're going to be using a calculator. But without a calculator, if you're going to have to solve this with a manual computation, then you're going to probably want to line this up vertically. So as an example, 3 times 4 is 12. You're good to go. And some terminology, just remember if I say 3 times 4, the product of those two is, product means multiplication, the answer to that multiplication problem. Okay. So now we're looking at a step-by-step guide as to how to solve something like 25 times 34. When we're looking at 25 times 34, we're going to focus first on the multiplier, and we know that the first number to the right is a 4. That's the first one. And we're going to take this 4, and we're going to essentially take 25 times 4, 25 times 4. All right, so to do 25 times 4, let's just run that. So 25 times 4, 5 times 4 is 20. That's going to be a 0 here. We're going to bring the 2 up. Pretend there's a 2 here. 2 times 4 is 8. 9 and 10, we add those 2 to the results of the product. 8 plus 2 is 10, so we have 100. So 25 times 4 is 100. Bingo, we've done that. And now what we're going to take is 25. You think of this as 3, but really this is 30. This is 30 because we've already taken care of the 4. It's 30 times 25 times 30. But, we're going to kind of ignore that there's a 0 here and just go with the 3. So 25 times 3 with a carryover. Where's the carryover? Carryover is right here. So we're going to start our numbering system to align with that 3. We'll start the numbering system. So 3 times 5 is 15. We'll put the 5 here. We're going to carry the 1 up. All right, so there's a 1 here. And then the next product is 2 times 3, which is 6 plus the 1 is 7. That's 7, 5. Making sure that we've started with this alignment. We started at where the 3 is. And this is left blank. Some of you, when I do this, I like to just put a 0 in there just to make sure that I see that it's not just a mistaken alignment that was intentionally moved over. So I would have 750 here. So 750, there'd be a 750 here. All right, so now that we have 100, and really 100 plus 750, 100 plus 750, because if there were 0 here, you would see 750. We add them up, but the 0 plus 0 is 0, 5, and 1 plus 7 is going to give 8. So the answer is 850. So if we go back to the original problem, 25 times 34, the product of 25 times 34 is 850. Now, in some cases, we may have something like 150 times 70. When you see this, there's 2 zeros here, and really to include those zeros makes it more complicated than it really needs to be. Now, you can't forget that you're getting rid of zeros here, but let's just go ahead and get rid of those zeros. We'll get rid of the zeros now, and let's just do 15 times 7. So when we do 15 times 7, we'll come up with 105. But now we took 2 zeros out, so let's put them on the back end. Once we put them on the back end, we have 10,500. That is the result. That is the answer to 150,000 times 70. Same with here, we have 300 times 90. We might decide to just get rid of all the zeros here. There's 3 zeros we're going to get rid of. So we get rid of them, pretend they're not there, and just do 3 times 9. That's 27. And then just add back 3 zeros. There's the 3 zeros. So 300 times 90, 300 times 90 is 27,000. The next section is dividing whole numbers. We're going to have to remember or have some memorization of some things. You have a dividend divided by the divisor. You take the dividend divided by the divisor, and that's going to equal the quotient. Whenever you see the term quotient, that's referring to division. So as an example, 15 divided by 5 equals 3. That's probably something you can have memorized. But you can also write this in the same manner of 15 divided by 5. That's like a fractional representation. 15 divided by 5 equals 3. To solve 15 divided by 5, or the way you might be thinking about this is 5 goes into 15 how many times? So in doing so, we'll take the divisor, place it on the outside of the divide sign, and then 5 goes into 15, which then allows us to solve for it using the step-by-step process of division. 5 goes into 15 3 times. 3 times 5 is 15. There will be no remainder. And so we do that as well to divide 1,095 baseball cards evenly among 73 collectors. You would take the 73 and divide it into 1,095. And so 73 goes into 1. That's not going to happen because it's going to be less than 1. So we add the next decimal place is 0. So 73 into 10. That's not going to work here. So 73 into 109, that does work. So that's going to be 1 time. 1 times 73 is 73. So now we're left with 109 minus the 73. That gives us 36. We're going to take the next decimal over from the 9 and bring it down. So now we're going to look at 365. 365. How many times does 73 go into 365? Now, the question may be, sometimes this is trial and error. You might plop in a number here because we're at the point where we have a 1. We're trying to figure out what this number is. And it could be that you're going to use trial by error, but one way that you could to try to cut down the number of times, or at least have a good starting point, is to pretend, just take 1 digit off each of these numbers. So in other words, let's take this away, and now we're looking at just the 7. And we have 365 here, but let's get rid of that 5 here. So now we're looking at the 7 and the 36. And how many times does 7 go into 36? Well, you should know. And if you don't, that's okay. Just go in and go back and practice your multiplication tables. But 5 times 7 is 35. You should know that. So you're thinking, okay, well, 7 goes into 36 at least 5 times, because 5 times 7 is 35. So we'll go ahead and use that as the starter point. We don't know for sure if it's going to work every single time when we do this, but we'll go ahead and start that off. We'll try the 5. 5 times 7 is 35. Well, first of all, since we now are going to use the 5, we're going to take the 5 times 3. 5 times 3 is 15. We'll put the 5 here. So far, it's looking pretty good. We're going to carry a 1 over, so 5 times 7 is 35, and we're going to add the 1, that's 36. So now we have 365. So it turns out that in this problem here, it's even. 73 goes into 1095 how many times? 15 times, and it goes into it evenly. Now, there can be a circumstance, in most cases, in fact, that's what's going to happen, especially when you're dealing with larger numbers, that it's not going to be even. And so there are a number of ways we can present the results. We could present it with a remainder. We could present it in a fractional form, or we could present it in a decimal form. Okay. When you're actually doing your homework problems, you're going to have to go through and see specifically what the homework is expecting, whether they're asking it for be with a remainder, a fractional, or decimal. Okay. So this example here is to divide 108,000 by 900. So the divisor is 900. 900 goes into $108,000. Well, one of the tricks that we learned earlier, we can do that again. Let's get rid of some zeros here, because that just makes it more complicated. We can get rid of 2 zeros here. If we're going to get rid of 2 zeros here, let's get rid of 2 zeros here. So with that, then we're going to look at 9 goes into 1080. If we drop the 2 zeros, we'll be able to, from both sides, we'll be able to use that as a way of solving the problem. So 9 goes into 1080. 9 goes into 10. We can't go into 1 because 1 is less than 9. So 9 goes into 10. Well, that's going to be 1 time. 1 times 9 equals 9. And then we're going to take the difference between 10 minus the 9. That gives us 1. We're going to drop down the 8. We'll bring down the 8. So now we're going to look at 9 goes into 18. How many times? Well, that's 2 times. 2 times 9 is 18. We're going to subtract the 18 from the 18, and that's going to give us a 0. There's one more 0 that comes down, so everything is 0. We're going to carry up the 0. So when we're trying to solve 108,000 divided by 900, then by dropping the 2 zeros on both numbers, we made it simpler for us to solve, and the answer is going to be 120. Now, the simplest way, and we might have learned when we don't have an equal divisor, when it just doesn't work, the simplest way to, I guess, when we were first taught division, they taught us the remainder concept. So as an example here, 716 goes into 26,495. Well, after we work all the numbers through, you can practice how this is done. We end up with 5,015, and we ended up using 7, and then 7 times 7, 16 is 5,012. We take the difference, we end up with 3. Now we're on the ones column, so anything to the right of that is either going to be decimal or a fraction. Or we could just call it square here and just say, let's go ahead and tap out from here. We're just going to say it's 37 times with the remainder of 3. And that's how you would present it. 37 R3, remainder of 3. In this example here, we ended up with 6. we tapped out, we've gone to the ones, we'd end up going to less than 1 or in the tenths place. So if we're not willing to do that, then we're going to have to represent this 6 as a remainder. So it's going to be 85 with a remainder of 6. Okay, that takes care of 1.1. The next video would be 1.2.